Why do over 90% of construction projects worldwide use recycled steel? The answer goes far beyond simple economics or convenience. Recycled steel has become the backbone of modern construction, shaping skylines and infrastructure in ways that are both innovative and sustainable. It's not just about saving money, recycling steel is transforming our entire industry. Every time a new building rises, chances are it's supported by steel that's already lived a previous life. This cycle of reuse is revolutionizing how we think about resources, waste, and the future of our cities. Let's dive into how it all works. Steel recycling is a game changer for civil engineers, offering not only environmental benefits but also new opportunities for innovation in design and construction methods. Here's how the process works, step by step. It's a fascinating journey that takes discarded metal and transforms it into the strong, reliable material that supports our bridges, skyscrapers, and homes. First, we collect used steel from demolished buildings, old cars, or appliances. This initial step is crucial, as it turns what would otherwise be waste into a valuable resource. Think about the sheer volume of steel that's available from structures at the end of their life cycle, or from vehicles and household items that are no longer in use. Imagine taking the beams of an old Hong Kong bridge and giving them new life. Instead of ending up in a landfill, these beams can be repurposed for new projects, preserving history while reducing environmental impact. Each piece of recycled steel carries a story, connecting the past to the future. Next, all that steel gets sorted, usually with strong magnets, since steel is ferromagnetic. This step is both efficient and effective, allowing recyclers to quickly separate steel from other materials in a busy facility. This helps separate it from materials like aluminum or plastic. By isolating steel, recyclers ensure that the final product is pure and ready for the next stage. The sorting process is a blend of technology and precision, making sure nothing goes to waste. Then it's shredded into small pieces and cleaned to remove things like paint or rust. This cleaning process is essential, as it ensures the recycled steel meets strict quality standards. Removing contaminants not only improves the strength of the final product, but also makes the melting process more efficient. Now comes the hot part, literally. The shredded steel is ready for its transformation, and this is where the magic of metallurgy takes center stage. Shredded steel is melted in electric arc furnaces at temperatures over 1,500 degrees Celsius. These furnaces are marvels of modern engineering, using powerful electric currents to turn scrap into molten metal. The process is fast, efficient, and far less energy-intensive than traditional steelmaking. This uses less energy than making steel from scratch, and cuts carbon emissions in half. By recycling steel, we're not just saving resources, we're actively fighting climate change and reducing the environmental footprint of construction. After melting, impurities are filtered out, and sometimes extra metals are added to meet specific standards, like boosting nickel for stainless steel. This customization allows engineers to create steel with properties tailored for different uses, from earthquake-resistant beams to corrosion-proof supports. The molten steel is then shaped into new beams or rebars and tested to make sure it's just as strong as new steel. Rigorous quality checks ensure that recycled steel meets or exceeds industry standards, giving engineers confidence in every project. Why does this matter? Recycled steel saves raw materials, lowers costs by up to 30%, and keeps tons of waste out of landfills. It's a win-win for the environment and the economy, making construction more affordable and sustainable for everyone. For civil engineers, it means building greener and smarter for the future. By embracing steel recycling, we're not just constructing buildings, we're creating a legacy of sustainability, innovation, and responsibility for generations to come.